Hello, today we will be solving this problem from CSES. It's called room allocation. So let's read the problem statement. There is a large hotel and end customers will arrive soon. Each customer wants to have a single room. You know each customer's arrival and departure day. Two customers can stay in the same room if the departure day of the first customer is earlier than the arrival day of the second customer. What is the minimum number of hotel rooms that are needed to accommodate all customers? And how can the rooms be allocated? And for the input, the first input line contains an integer n, the number of customers. Then there are n lines, each of which describes one customer. Each line has two integers a and b, the arrival and departure day. Print first an integer k, the minimum number of rooms required. After that, print a line that contains the room number of each customer in the same order as the input. The rooms are numbered 1 through k. And we can print any valid solution. N can be as large as 2 times 10 to the 5th, and A and B can be as large as 1 billion. Like in this example, there are 3 customers. The first one will be at the hotel from 1 to 2, the second from 2 to 4, and the third one from 4 to 4. See here, the departure time of the first customer is the same as the arrival time of the second customer. So these two cannot be in the same room. That's why we assigned the first customer to the first room, then the second customer got another room, and finally, for the third customer will arrive at time 4. So the first room will be free by then. That's why we assigned the same room to the third customer. So let's go ahead and see how we could solve this problem. So this is our first example. As we said, we would assign, at the beginning, there are no rooms assigned. So this first customer will come and it has to get some room. So we will just give it room number 1. So this customer gets room number 1 and he will hold it from 1 to 2. This second customer arrives and there is a room in use. And we need to give him another room. So he gets another room that he will hold from 2 to 4. Then this third customer arrives and he will arrive at time 4, and by then this room will be free. So we will give him this room. So what you can notice here, so this room will be taken by the third customer from 4 to 4. What you can notice here is that the arrival, these times are important, and we cannot just process the customers in any order we want. So it is better to sort them by arrival time. That way, for example, if there was some other customer that would come from 1 to 3, we would need to process this customer first. So this is the first remark. We have to sort customers by, say, arrival time. Okay, now that we have sorted them, what is the idea that we could use? So basically the idea is pretty straightforward. If there is some room available to give, we would just give it to that customer, and if there are none, we would have to assign a new room. Let's check out another example and see how this could help us. So here is another example. As we said, the first thing we would need to do is to sort these customers by arrival time, and in case of of equality, we would sort them by departure time. So this would give us 1 3, 1 4, so we took care of this one and this one, then 2 2, then there is no 3, so 4 8, then before 4 8 there is 4 5 and 4 8, so 4 5, 4 8, 5 7, 5 8, 6 8, 8 8, and 8 9. Okay, so as we said, let's process these customers. So this first customer will come. There are no rooms assigned so far, so we'll just give this room to the first customer. So room 1 will be taken from 1 to 3. Let's just write down the second number. So it will be in use up until 3, and T so far is still 1. Then this second customer will come, and the same thing will happen. We have a room in use, and it won't be free until the customer's arrival time is strictly greater than 3. So we cannot accommodate this customer. That's why we need to create a new room for it, and it won't be free until time 4. Then the third customer will come. Is there any room that is free that we could assign to this customer? No. So we need to create a new room for it, and it would be in use till time equals 2. So we gave this customer room 1, this one room 2, this one room 3. Now we are at the fourth customer, and are there any free rooms? And the answer is yes, because now the time we are at time 4, and this we will go through the rooms and we'll find that this room, like the room that became empty first, was this one. It got freed at time equals 2. So we will just give this room to this customer and update the usage of this room to 5. Then comes this customer. Are there any free rooms? And the answer is yes. This room was free at time 3, and now we are at time 4. So we'll just give this room to this customer and update this to A. Okay, this room is next. Are there any rooms that will be free at some time that is strictly less than 5? And the answer is yes. So this room will be free, and it will be, now we will assign it to this customer, and it will be in use till time equals 7. Now we are at this customer, and you can see here that the usage of all these rooms is at least equal to 5. So there is no room that will be free that at some time that is strictly less than 5. That's why we need to create a new room and assign it to this customer and record that this room will be in use till time equals to A. Now we are at customer 6. Are there any rooms that will be free at some times that is strictly less than 6? And the answer is yes, room number 3. So we'll assign room number 3 to this customer and update this to A. Now we are at this customer. Are there any rooms that will be free at some time that is less than 8? And the answer is yes, room number 2, and we'll update this to A. And finally, we are at this customer, and we need to check if there are any rooms that will be empty at some time that is strictly less than 8. And the answer is no. So we need to create a new room 5, and it will be in use till time equals 9. So we'll assign 5 to this customer. As you saw here, what we did was pretty straightforward. If there are no rooms at all, we create a room as we did with the first customer, and we just assign it. Let me copy this example here. and let's bring it up. So we could write what we would do. And let's bring it over here. Okay. So we said we needed to sort our customers by arrival time and depth in case of equality. Then we said if no room, assign room. We would do this at the very beginning. Then what we did was that we were checking all rooms to see if some room would serve the purpose. But this could be costly, because imagine if you have n rooms, or let's say m, to not confuse it with our variable. If we have m rooms and we need to check for some customer if there are any suitable room, we would need to go through all these m rooms. And if we do this for all customers, the complexity would be something like n times n. And in the worst case, like if each customer gets a new room, so we would assign a new room for this one, then we would assign a new room for this one. So we would have 2 rooms by the time we get to this third customer. That means that for this customer, we would need to check 2 rooms. And for this customer, we would need to check 3 rooms, and so on. So the complexity would be n squared, because it would be something like, for this customer, we wouldn't need to check anything, so it would be 0 plus, and for this customer, we would need to check 1 room plus 1. And for this, we would need to check 2 plus 3 plus 4, and so on, till n minus 1. And this sum is equal to n times n minus 1 over 2, which is asymptotic to n squared. So this is bad. But there are a few things we could notice. We could notice that if the room with earliest, if the room that will be available at the earliest time is not suitable, then no rooms will be suitable. For example, if we have something like this, if we had like 4 rooms, and this was the time they would become available. Like if we check these 3, and our customer wants to get a room from time 3 to 10, for example. If we check these 3 and it's not suitable, then evidently 4, nor 5, nor 6 would be suitable. Because if the earliest available room is not suitable, none of the others would be suitable. That's why we only need to check the room with the earliest availability time. So how could we know which room has the earliest availability time? There are different ways we could approach this. We could keep these availability time in a multiset, for example, and the iterator at begin would give us the earliest room that will be available. We could also use a priority queue, and this is what we will use in our actual approach. So a priority queue is a data structure that holds values, and if you check, let's call that our queue, let's call it, for example, k. If we check k dot top, this would give us the value, that the smallest value or the largest value, depending on whether we use a less or greater comparator. So this would actually give us the smallest value in our queue, and this would help us solve the problem. So let's go back to our approach. So we said if no room, assign new room. Otherwise, check priority queue. If top, is strictly less than arrival time, take room, else assign new room. And that's pretty much it. So in our priority queue, it will hold, we could represent it by a pair of ints. So our priority queue, we could define it as a pair of ints. And this pair will hold two values. The first one is the time it becomes available, and this will be used for comparison. And the second value will be the ID of the room. So we check the room with the smallest availability time. If it is less than, let's try an example. Say we have a customer that wants a room from 4 to 10. We will check k.top. Say the k.top would give us something like 3, and the ID of the room is 2. So we will assign 2. We will assign 2 to this customer, and we will update this value. So we'll erase this value from our queue, and we will push a new value into it, which would be 10 2. This means that this second room will be free after time equals to 10. And that's pretty much it. A few things about priority queues. Insertion and deletion are in log n, and all operations, so insertion, deletion are in log n. Checking the top is O of 1. So our total complexity will be n log n. So let's check out our code. So we'll start by reading the input. We said we have n customers, and we will hold our customers in this vector. It's a vector of pairs of ints and int. This int here will store the actual index of the customer, because remember we said we're gonna sort our customers. So if we sort them, we're not gonna have the same order as the order that was given to us, but at the very end we will need to print the rooms we assigned to each customer. So we need to remember the order we had in order to print this list. And in order to remember that, we keep the initial index here. And for this pair, the first value will be the arrival, and the second value will be the departure time. So we look through all our customers, then we will read the arrival time. So this would be first dot first, then we will read the departure time, and here we will assign this value to the index of our customer. That way when we sort it, we can retrieve the initial order. Then as we said, we're gonna sort customers. The default comparator would work here, so it would sort them because this is the first value, which is the arrival time, so it will just sort them by this value. Then we will declare a vector. This is the vector that will hold our answer. So this vector holds the room assigned to each customer. This int here is the ID of the rooms. We will start with ID 1, and this will also allow us to retrieve the number of rooms we used. Then we will declare a priority queue. And to declare a priority queue, we have to specify three things here. The first one is the data type that our priority queue will hold. And we said we're gonna hold a pair of ints, so that the first value here will be the time when this room will become available, and the second value is the room ID. Then, since we are using pair of ints, we need the container that will hold them is a vector of pair of ints, and here we have to specify the comparator. Here we are using greater because we want the smallest value to be on top. If we wanted the largest value to be on top, we would use less instead. And then we will look through all customers, so we would assign the rooms to them. And our first case, if no room has been assigned so far. So if the size of rooms is 0, we will assign. See here, that's why we kept the ID of the customer, the initial ID of the customer. So customers I.second holds the initial ID of the customer. So we would assign room assigned to room ID plus plus, and we increment this room ID so that the next room will have a different ID. Then we push this room we assigned into the queue. And as we said, to push a room into the queue, we have to specify two things. The time it will become available, and it is clearly customers I.first.second, which is the departure time of this customer, and then the room ID. I'm using room ID -1 because I just incremented it here, and I wanted the value that I actually gave to this customer. And then else, if there are already rooms assigned, I have to check for one thing. I have to check that the room on top of my queue, that is the room with the smallest availability time, is less than my arrival time. So that's what I check for here. So if rooms.top.first, this is the availability time of the first room, is less than customers.first.first, then I'm gonna use this room, which means I have to note that I will assign this room to this customer. So here I retrieve its ID and I assign the room.top.second. This holds the ID of the room on top of my queue to it. Then I retrieve this pair that was on top. I store it in this variable x. I pop my queue, that is I remove this value from my queue. Then I'm gonna push a new value into it, and the new value is gonna be obtained from the departure time of this customer and the room ID, and that was stored here in x.second. Okay, otherwise if the room on top of my queue is not available, then I need something else. I need to use another room, and that's precisely what I do here. So this is identical to what I did here. So if no rooms are suitable, I need to use a new room, and in order to do that, I will assign the room for this customer to a new room, and then I will just push this pair into my queue. This means that the room I just assigned will be free at the departure time of this customer. And at the end, I just print the rooms I used, because I have a -1 here, because remember, each time I use a room, I increment it. So the value I gonna have at the very last will not be used. That's why I decrement it by 1. And at the end, I just print this vector, rooms assigned. So I just look through all the values from 0 to n and print them. So that's pretty much it. Let's go ahead and submit. So that worked. Thank you very much for watching. See you in the next video. Bye bye.